everybody, and welcome to Sequences in Series. We are doing the geometric sequence, and in this video, we're having a look at some exercises. So if you have not watched the first two videos on geometric sequences, please watch the first two videos first before going through this video. So in this video, we are looking at some exercises. We have three patterns over here, three geometric patterns, and for each of them, we have to find the general term and the 100th term. So let's start with the first one. And I encourage you to pause this video and attempt it by yourself before watching the solution. So the first one, I'm going to write it over here. For number one, we have fifth, 5, a 1, and a fifth. So we have to find the general formula, we have Tn is equal to A R to the power of n minus 1. So we have to fill in what's A and R. So you'd remember from the previous video that the A is the first term, so that is 5, and the R is the common ratio. So we get the R by dividing any term by the term before it. So R, for example, can be T2 divided by T1, which is 1 over 5, so it's a fifth. And then all we have to do is then simplify. So Tn is equal to 5. This we can write as 5 to the power of 1 minus n, switching the signs of the exponent to bring that 5 to the numerator, and then we can simplify as 5 to the power of 2 minus n. To calculate the 100th term, then it becomes quite simple. We just substitute 100 in the place of n, and this is 5 to the power of minus 98. I don't think your calculator would be able to give you the answer, so you can leave it in that form. Let us have a look at the second one. So for the second one, we have 3, 6, and 12, so on. So again, our formula is T is equal to A to the power of, AR to the power of n minus 1. So to solve for Tn, we're going to have to substitute A and R. So A is our first term, which is 3, and R is our common ratio, which we can get by dividing any term by the term before it. So T2 divided by T1 is 2, so our R is 2. And that's the power of n minus 1. And then again, we just simplify this here because the bases are not the same. This is the simplest that we have it. To calculate T100, we then just substitute 100 in the place of n. So we have 2 to the power of 100 minus 1, which is 3 times 2 to the power of 99. Again, you can leave it in that form. Now the third one, this freaks out a lot of people when they see variables and alphabets. You do not change the process stays the same. So we have Tn is equal to our first term, A times R to the power of n minus 1. So then again, we're going to do the exact same steps where we're going to substitute A and R. So A is our first term, so it's A times x plus 1. And R is our common ratio, so we can get it by dividing any term by the previous term. So I'm going to say T2, which is A x plus 1 squared over A to the power, times x plus 1. The A's cancel out, one of those cancel, leaving us with x plus 1. So our common ratio is x plus 1, and that's the power of n minus 1. Now we can simplify the A's by itself, and then x plus 1 times x plus 1 to the power of n minus 1 is x plus 1 to the power of n using our exponential laws, and that is the general formula. To then find the 100th term, we then say A times x plus 1 to the power of 100, and we can leave it in that form over there. I hope that you've understood the contents of this video. Please watch our next video for more examples on geometric sequences. Thank you. Bye.